Calculus explained to a non-calc student in 3 minutes. Does my voice sound like I'm a little sick? Well, I am. Sick of calculus. Are you taking calculus next year? No? Well, here's a preview of what you'll be learning next year. Limits are at yours because frankly I'm at mine. Limits are basically what happen when you zoom in infinitely somewhere and predict what happens there. To find the limit as x approaches 4 of a graph, you just kind of zoom, and wow, it looks like as x goes to 4, y also goes to 4. But wait, you might be saying at exactly x equals 4, y equals something else. Look at him being special. Well, firstly, don't interrupt me, and secondly, we'll just forget about him. He does not matter. See, when we zoom in infinitely, both the left and right side get closer and closer to 4, so any sane person, that'd be you, a non-calc student, could predict that maybe as x goes to 4, y equals 4, since it makes the most sense, and that's limits. But wait, I hear you saying again, what about limits to infinity? And to that I say no. Derivatives. Derivatives are basically the slope at a single point on the graph, and that doesn't make any sense because you need 2 points on the graph to calculate the slope. Yeah, it doesn't make any sense, but you just have to pretend it does if you want to pass the class next year. Well, using limits, we can take 2 points with an infinitely small change in the graph to calculate it, and essentially, it would be the slope at a single point. Why would anyone do that? Who knows? After the scientists running the Manhattan Project successfully created the atomic bomb, they cried in regret, so I don't know why Newton had the audacity not to do so as well after creating calculus. Alright, so when you take actual calculus, you'll learn some neat tricks to find the function that tells you the slope on each point of a graph. For example, this one, x to the 7th. You just move the exponent in front and minus 1 from the exponent. To find the derivative of that new function, you just do it again. Easy, right? With derivatives, you can do some neat tricks like related rates, where you see how rates are related by differentiating both sides with respect to time. Some new guy who just suddenly showed up to make calculations even more complicated. You can calculate how area changes in relation to the radius, how much a man's shadow grows as he runs away from a lamppost, how many sanity degrades as the year goes on. You can do all of that by learning the difficult but rewarding discipline of related rates, or using Wolfram Alpha. Integrals. Integrals are an integral product calculus, so it's important to integrate them into your brain. Integrals were probably created when some wise guy decided that he loved math so much that he wanted to underivatify a function, and they were like, oh shoot, this gives the area of the function. That's really, really cool. So yeah, doing the opposite of taking the derivative, you can actually find the area below a curve but above the x-axis. Oh, that's easy enough. I'll use my trusty French product rule. Of course you will. Nope, they don't exist anymore. And when things couldn't get any harder, the integrals just start going throughout the graph. Yeah, and then to find the volume of this monstrosity, your good old friend Pi comes back from the depths of math analysis to haunt you again. And you have to find the radius of the outer thing, which is called big R, and inside, which is called little r, and you take the square of the difference of them. But wait, who told you it's gonna be from the origin? Haha, silly. You have to sometimes move the revolution point, and oh look at that, it changed direction, so now you have to write everything in terms of y. But wait, you can just use another method. Yep, a whole brand new method where you have to find p of x and h of x, and don't ask me what p of x is, because I don't know. And as you're finally starting to understand this mess of mathematical jumbo, boom, the AP exam hits you right in the face, and out of nowhere, you'll end the whole year wondering what just happened for 10 months. The answer? Calculus.